Direct proofs are most common, but there is another way to do a proof when you have a hypothesis and a conclusion, and that is an indirect proof. And the most common indirect proof is by contrapositive. And the strategy here is assume the conclusion is false and use that to argue the hypothesis is also false. So in a direct proof, you start with the hypothesis being true and you prove the conclusion is true. It's sort of the most natural way to do it. But in an indirect proof, you reverse all that and you say, well, suppose what I want to say is true is actually false, and then you show that that actually means the hypothesis must have been false to begin with. And if you think about it, that's logically equivalent. That's the same thing. So here's an example. Let x be an integer. If x squared is not divisible by 4, then x must be odd. Okay, so now just you should always try a direct proof first. That's usually the easiest way. In this case it won't, but usually it is. And you'll see why it isn't in this case, because the hypothesis here is that we have an integer x and x squared is not divisible by 4. And in this particular case, it's that not that's killing us, because x squared is not divisible by 4. That's a sort of a negative thing, right? That's saying something is not true right off the bat. So what do you have to work with there? See, if x squared was divisible by 4, you could say, okay, x squared is 4 times k for some integer k, something like that. And you would have something to work with, something to hold on to. But it's not divisible by 4, so what is it that you can write down that stems from that? Not much. So that's a time when a direct proof kind of fails you, and maybe an indirect proof is going to be better. So first of all, let me I will write the first hypothesis that x is an integer. Okay, but then for the rest of it, for that if-then statement, I'm going to do this indirect proof. I'm going to assume the conclusion is false. Suppose x is not odd. Now, let me say right off the bat, I'm going to change that. Not odd, there's a better way to say not odd, which is even, right? So suppose x is even. So that's the sort of negating the conclusion I want to get to. Suppose that's not true, that x is odd. Well, then x is even. And now what I want to prove is that the hypothesis is also false. I want to say that x squared not divisible by 4 is false. Well, if x squared not divisible by 4 is false, then x squared is divisible by 4. So I want to prove that x squared is divisible by 4, basically. All right. So that's where I want to get to, that x squared is divisible by 4. Well, okay, x is even. So I know that I have something I can write down based on that. I can say x equals 2 times some integer k. All right. And then I want to prove that x squared is divisible by 4, so let's look at x squared. And since x is 2k, I can say 2k squared. And of course that equals 4k squared, and this is working out really nicely. Let me make that its own line. Not its own line, but it's start of a new line. So x squared is divisible by 4. Okay. And then maybe just as a concluding sentence, I don't have to do this, but as a concluding sentence I'll just say, therefore, if x were not divisible by 4, then x would be odd, right? Because we know if x is even, then, oops, I'm sorry, I forgot that squared here. Yeah, if x squared were not divisible by 4, then x would be odd, and that's what we wanted to prove. Because if x is even, x squared has to be divisible by 4. That's what we just proved in these two lines. So that's an example of an indirect proof, a proof by contrapositive. So that can be used to your advantage sometimes. And like I said, usually you try a direct proof first, but these indirect proofs work when if you try a direct proof and it's kind of a negative, if your hypothesis is a negative thing or something that does not really let you write something concrete down from it, then you might try contrapositive. You might try the indirect proof. It might work in that case. Okay.